All right, quarantines, happy Monday. I want to take some time and make a video about the different kinds of bonds that we've talked about in class. So we have ionic bonds, we'll start out with those. And ionic bonds they form when one atom transfers electrons to another. And this creates what we know as ions. Now, ions are any atom that has a charge. Now, these have some pretty cool properties. Ionic compounds will typically be taking time to write words down. They will be more brittle and hard. And this comes from the fact that they form very crystalline structures. They're very well organized and neatly arranged. And when they pack in tightly in that kind of structure, it makes it more difficult for them to melt or eventually boil. So they have very high melting points and boiling points. Let's see. They are easily dissolvable, they're very soluble. And they can conduct electricity in solutions or when they are melted. Let's see this. Alright, so let's draw some ionic compounds. And I'm going to block off the space specifically for this. Let's draw, first one will be an easy one. NaCl, salt. So we know that sodium, Na, has one valence electron. Remember, this is how you draw your Lewis dot structures. Chlorine has 7. Remember to pair them up, 2 on each side. And don't pair them up until every side has 1 electron. Now what happens is each atom wants to get closer to a full valence shell. For sodium, that actually means getting rid of that 1 electron that is holding it back. However, chlorine wants to pick up an electron, because getting 1 electron is easier than trying to lose 7. Now this causes sodium to have a positive 1 charge because electrons are negative, and chlorine now has a negative 1 charge because electrons are negative. It has 1 more electron. And then you would just write this out as NaCl. Let's do another one. I don't like how the writing is showing up today. Oh well. Let's do magnesium bromide. Oh, actually, let me back up. NaCl, whenever we name these, the first element, which is always the cation. Remember, cations are the positive ones, like cats. First one is cation, and so you'd write sodium. And then you write the name of the anion, but you add "ide" to the end. Sodium chloride. Just like that. Let's go ahead and do magnesium bromide. Magnesium and just do it like this. So I'll start with magnesium because that's going to explain why we have MgBr2. Magnesium has 2 valence electrons, and bromine has 7. Now, this bromine can only receive 1 electron. If it has 8 valence electrons, it will not take on anymore. It is full, it is happy, it is satisfied. So, magnesium still has an electron to get rid of. That's where the second bromine comes in. This bromine will receive that electron, and we'll go right on over. And that's how that's going to be. You'll end up with magnesium with a +2 charge, and then 2 bromines, each with a -1 charge. And this can just be written as MgBr2. Now the name for this would be magnesium. Let me fix that. Bromide. We did a whole bunch of practice with naming compounds. Feel free to go back into Google Classroom and do some more practice on that. It'd be a great way to spend your quarantine. Let's go ahead and do aluminum oxide. I'm actually going to give you the name first. Now, there's a trick to this. And I'm going to show you the trick in a moment, but first, let's draw aluminum. So you have aluminum, and it has 3 valence electrons. Let's draw an oxygen, and that has 6 valence electrons. Aluminum is ready to give away its electrons. So, aluminum gives away 2. Now this oxygen is satisfied, but aluminum still has 1 more electron to give away. So we'll set up another oxygen. Give that oxygen an electron from aluminum, but unfortunately that's the only aluminum electron left. So we actually have to add another aluminum to give more electrons to this oxygen. See the same thing happening. It gives away that electron. Now there's 2 left to give away. Throw in another oxygen. And then it's all set. Now you'll see that each aluminum atom gives away 3 electrons. That means each aluminum has a +3 charge. Each oxygen receives 2 electrons. That means they have a -2 charge. A good trick, if you can figure out the charges on the atoms is to see what the charge is on the cation. In this case, the aluminum has a +3. That tells you how many of the anions you're going to have. So we have 1, 2, 3 oxygens and a +3 charge on aluminum. If you look at the charge on the cation, that tells you how many charge on the anion tells you how many cations you have. 1, 2 aluminum. So you should have Al2O3. And that's your aluminum oxide. These take some practice. I did not include any ionic bonds where they have a variable charge. We can always do that in another video. But yeah, for now, get this, write it down, take notes, and I hope to see you all soon. Have a good one.